Minutes ago, scientists worldwide were shaken by an astonishing discovery made by the James Webb Space Telescope, a galaxy older than the universe itself, hurtling towards Earth at incomprehensible speed. What does this mean for humanity? Is this the sign of an imminent cosmic catastrophe, or the unraveling of universal secrets that could rewrite science as we know it? Let's explore the unsettling truth behind this galactic revelation. Introduce Jade's GSZ-14. Explain its significance as the brightest and most distant galaxy ever observed, surpassing the previous record holder, Jade's GSZ-13. Its formation occurred a mere 290 million years after the Big Bang, during the universe's infancy. Mention why this galaxy has sent shockwaves through the scientific community, challenges existing models of galaxy formation and cosmic timelines. Raises the possibility that our understanding of the universe's age and formation might be incomplete. In the infinite tapestry of the cosmos, humanity has always gazed upward, seeking answers to profound questions. How did the universe begin? What lies beyond the reach of our telescopes? Are we alone? Each scientific milestone brings us closer to understanding our cosmic origins, and one recent discovery has set the astronomical community ablaze with excitement and curiosity: the identification of Jade's GSZ-14, a galaxy so ancient and unique that it challenges our understanding of the universe itself. This extraordinary galaxy, detected by the James Webb Space Telescope, JWST, is unlike anything astronomers have encountered before. At an astonishing redshift of 14.3, Jade's GSZ-14 pushes the limits of what we know about early galaxy formation. Redshift, a measure of how much the light from an object has stretched due to the expansion of the universe, serves as a cosmic timestamp. The higher the redshift, the older and more distant the object. Jade's GSZ-14's redshift places it at a time just 320 million years after the Big Bang, a period often referred to as the Dark Ages of the universe. But why is this galaxy so significant? Jade's GSZ-14 defies the conventional wisdom about the formation of the first galaxies. Its brightness and mass suggest that it formed and matured in a remarkably short time after the Big Bang, raising questions about how such a galaxy could emerge when the universe was still in its infancy. For decades, scientists have relied on models that suggest galaxies of this scale and complexity should not exist during this epoch. Jade's GSZ-14's discovery shatters these models, forcing a re-evaluation of our understanding of the cosmos. To appreciate the magnitude of this finding, consider the conditions of the early universe. After the Big Bang, the universe was a hot, dense soup of particles, gradually cooling as it expanded. For the first several hundred million years, no stars or galaxies existed, only a dark expanse of hydrogen and helium gas. The Dark Ages ended with the formation of the first stars and galaxies, which reionized the universe and brought light to the cosmos. Scientists have long believed that the first galaxies were small and primitive, taking hundreds of millions of years to coalesce into the grand structures we observe today. Yet, Jade's GSZ-14 appears as a fully formed galaxy, complete with a level of luminosity and structure that should have taken billions of years to achieve. This anomaly raises a tantalizing possibility: either our cosmological models are incomplete, or Jade's GSZ-14 represents an entirely new category of early galaxy. The implications are staggering. If Jade's GSZ-14's formation timeline is accurate, it suggests that galaxy formation began earlier and proceeded more rapidly than previously thought. This discovery challenges the widely accepted lambda-cold dark matter, lambda-CDM, model, which has served as the cornerstone of modern cosmology. The identification of Jade's GSZ-14 is not just a milestone in astronomy, it is a testament to human ingenuity and the power of technology. The James Webb Space Telescope, launched in December 2021, was designed to peer deeper into the universe than any telescope before it. Equipped with cutting-edge infrared imaging capabilities, JWST allows scientists to observe celestial objects at unprecedented distances, capturing light that has traveled billions of years to reach us. Jade's GSZ-14 is a product of the JWST Advanced Deep Extragalactic Survey, JADES, a collaborative effort involving scientists from around the globe. The survey aims to study the earliest galaxies, shedding light on the universe's formative years. Through JADES, astronomers have identified numerous candidates for high redshift galaxies, but Jade's GSZ-14 stands out due to its extreme distance and unique properties. This discovery marks the beginning of a new era in cosmic exploration. Jade's GSZ-14 is not just a window into the past, it is a key to unlocking the mysteries of galaxy formation, the nature of dark matter, and the ultimate fate of the universe. Dive into what makes Jade's GSZ-14 unique: its unprecedented size, brightness, and chemical composition. The rapid emergence of oxygen, indicating advanced star life cycles in a young universe. How could such complexity arise so soon after the Big Bang? Are current galaxy formation models flawed, or is something more profound at play? Explore the possibility of pre-Big Bang galaxies. Could Jade's GSZ-14 and others like it suggest a universe existing before ours? Discuss theories like Roger Penrose's conformal cyclic cosmology. Touch on alternative theories. Is the accelerated expansion of the universe tied to interactions with other universes? Mention the soap bubble hypothesis and its implications for multiverse theories. Address the galaxy's movement toward Earth. Explain that while this is metaphorical, due to the expanding universe, the concept ignites questions about cosmic scale interactions. The mix of awe, fear, and scientific curiosity sparked by such discoveries. The importance of the James Webb Telescope in unveiling universal truths. The potential for finding even older or stranger galaxies with Webb's capabilities. How these discoveries might rewrite textbooks and reshape fundamental physics. What if we're only scratching the surface of a multiverse filled with galaxies and universes? Could these findings hint at a deeper, almost incomprehensible cosmic design? Jade's GSZ-14 is more than a distant speck of light, it's a key to unlocking secrets about the very fabric of existence. As we look up to the stars, we're reminded that the universe is vast, mysterious, and full of surprises. But what lies beyond this discovery? Could the next revelation be even more astonishing, challenging not just our science but our imagination? Stay tuned as the universe continues to unveil its timeless stories. What do you think about this discovery? Could it change the way we see the universe forever? Let us know in the comments. If you're fascinated by the mysteries of space, hit that subscribe button, like this video, and join